All right, so today we are going to go through section 2.6, which is looking at graphs of other trig functions. Specifically, we're mostly going to be focusing on, just the other four. So there's tangent, cotangent, cosecant, and secant. The last time that we were together, the video that we went through was going through sine and cosine, so this is pretty much going to be everything else today. There's a few things that I do want to point out. Again, there's a lot of information in the textbook, so I really encourage every single one of you to go check out all of that information, graphs, examples, all kinds of stuff. What I'm going to do is just go through real briefly what some of the properties are of each of these trigonometric functions. Specifically, we'll just start off at tangent and we'll work our way down. For the tangent function, again, take a look at the page on 181. But tangent actually has no amplitude. So if you remember, amplitude is like the maximum value and the minimum value. It's related to how high the curve goes. Now the problem with tangent is that it doesn't actually have a max height. There's a vertical asymptote, which means if you remember from college algebra, there's a point where the function will essentially go all the way up to infinity, and it will also come out of negative infinity. So there's a vertical asymptote that is at particularly these values. So they'll be at pi over 2, 3 pi over 2, and every pi after that. So you can see that there's between negative pi over 2 and pi over 2, there's pi in between. It's the same thing over here. There's pi in between negative pi over 2 and negative 3 pi over 2. So at every single one of these places, you're going to see a vertical asymptote, and the tangent function is going to basically shoot straight up, and it's going to come back down. The period is going to be a little different than it was for sine and cosine. So for tangent, it's actually going to be pi over absolute b, where b is this value right here. If you remember from the last time, it was from sine and cosine, it was 2 pi over absolute b. So tangent's just a little different. Cotangent actually is pretty much the same idea. The properties are identical. It's got asymptotes again at every pi over 2, and then simultaneously the period is going to be based upon the this equation, pi over absolute b, where b again is just going to be this value right here next to the x. Okay. The graph of the cosecant function. I'm going to probably show you just what these look like in the textbook so you can see, but again, just some of the properties. The properties are pretty similar. There is no amplitude for cosecant. Similar to secant, there's going to be no amplitude, and the period is going to be exactly the same as it is for the inverse function, which in this case is going to be secant. So, or sorry, not secant, sine for cosecant. So that means that it's going to be 2 pi over absolute b. Same thing for secant. It's going to be similar to what cosine is. So again, 2 pi over b. So a lot of this is really similar. Let's go ahead and talk. Let's go through some examples here in just a minute. But first, I want to go ahead and show you some of these graphs. I actually have the textbook, the physical textbook, right here in my office. So I'll go ahead and show you. Let me go ahead and zoom in here. Just give me 1 second. So let's go ahead and go back to this one here is going to be tangent. Okay, so you can kind of see, I don't know if you can see this very well or not, but you've got, again, this property where it shoots up and then it kind of reappears down below at the bottom. There's a vertical asymptote there, and again, it's at every pi over 2. There's some more properties that are listed right here. Again, I would encourage you just to go ahead and take a look at that. Same idea. on the future page, a few pages later, it's the same idea. Actually, the only difference between tangent and cotangent is that it looks like they're just reversed or flipped. So prior to, if you look real quick, let me go back. You can see how everything is kind of increasing up to the right. So it's boom, up, boom, up, boom, up, boom, up, like that. On the cotangent, it's actually the complete opposite. So everything is just going to be shooting straight down. Okay? So that's kind of the idea with that. The secant and the cosecant are a little strange because what you're basically doing on these functions is you're connecting the pieces that are kind of missing, if you will, in the inverse function. So in this case, sine is going to be the other function that's connected to cosecant. If you draw a sine curve like this, the cosecant is going to connect to pretty much the maximum and minimum points with asymptotes in between. Okay, so there's going to be an asymptote at pi, 2 pi, 3 pi, 4 pi. Every pi all the way out, there will be asymptotes for that function. And as you can imagine, for the secant function, it's pretty much identical. If you remember, cosine is just shifted by pi, right? So if you move it around, okay, it's the same idea. So you have 3 pi over 2. After 2 pi, what is that going to be? 5 pi over 2. So you can kind of see how these functions, they all relate to one another. They look similar. Tangent and cotangent ones are very, very similar, and the same goes with the secant and the cosecant. So, and the cool thing is you can get them directly from other functions that we've already looked at. So let's go ahead and I'm going to zoom out here, and then we're going to go through just a few examples. I don't really have very many. Many of the problems are fairly similar to one another, so hopefully that will help. But let's go ahead and just look at question 10. Okay. Here they ask to state the period. So we need to find the period of y is equal to 1/2 cotangent of 2x. Okay. So again, if I'm looking for the period, remember the period is going to be based upon this value here, but it is not that. The period is going to be based upon pi over absolute b, where this is b. Okay? Because this is cotangent, we're using pi and not 2 pi. So the period is going to be pi over absolute value of 2, which is equal to just pi over 2. I'm going to do a little trickier one. Let's do 14. We'll do y is equal to -3 cotangent of 2x over 3. And when you get something that's going to be like this, what you have to recognize is that you can pull the x apart from the 2/3. So this is pretty much the same thing as -3 cotangent of 2/3 times x. Okay, so your b value is just going to be that fraction right there. So remember, the period is going to be based upon pi over absolute b, which in this case is going to equal pi all over absolute 2/3, which is equal to pi over 2/3. Okay, and remember, when you have a complex fraction like this, you can multiply both the numerator and denominator by the reciprocal. Okay, and the reason why is because this is just 3/2 over 2, or 3/2 over 3/2 is just 1. So again, it just kind of makes it a little bit simpler. This is going to cancel with this. This is going to cancel with that. So we have, in this case, it's going to be 3 pi all over 2. Okay, so that's our final there. This is our final up here. And that's how you pretty much go about solving these problems. All right, let's see here. Let me do question 16. Y is equal to minus 1/2 cosecant of 2x, okay? So the period for this one is going to be 2 pi all over absolute b, okay? And in this case, you've got your b value is going to be there, which is 2. So 2 pi all over absolute 2, which is equal to 2 pi over 2. And the 2's cancel, so I'm left with just pi. Okay. So these ones are relatively straightforward. Usually it's kind of backwards, but you think of like tangent and cotangent, cosecant, secant as much more complicated formulas or much more complicated trigonometric functions, but in practice, the properties of those graphs are relatively straightforward. They're a lot simpler than they are with sine and cosine when you have a lot of things going on. So now what I want to do, I just want to show you how to graph some of these on a device, okay? Something you'll probably notice if you have a calculator with you, I'm going to show you how to do this really quick. Let me go ahead and zoom in. So one thing that I want to point out, I still haven't changed these batteries. I probably should do that here at some point. First off, let me zoom out here really quick. I want to show you something that is going to show up. You may be asked to graph on a calculator or device cotangent, cosecant, and secant. And you probably will notice your calculator does not have cotangent, secant, and cosecant. So the thing that we need to remember is that cotangent of x is the same thing as 1 over tangent of x. Okay? Cosecant of x is the same as 1 over sine of x. And secant of x is equal to 1 over cosine of x. So this right here is kind of the cheat sheet for entering these into your device. So I'm going to go ahead and show you how to graph some of these on a TI-84. Let's go ahead and take a look at question let's see. We'll do question 28. And 28 is just 3/4 secant x. So how do you put in secant? So here's what you're going to do. First, make sure I am in the correct mode. Technically, when you're graphing, it doesn't really make a difference. But I'm going to do radian mode just for the sake of it, because I want to get used to using that. So then my x min, we'll do oh boy, let's do minus 2 pi. And by the way, if you want to know where the pi button is, if you look, see where is it? It's right here. So you see the little caret button. There's the, I don't know if you can see it really well on this picture, but there's a little blue variable right there. It's not actually a variable. This is just pi. So you can pop it in. And notice when you drop down, it'll just put an approximation. And that's fine. It doesn't have to be perfect. We'll go up to 2 pi on that one. And then for the y min, we'll do minus 1 and 1. We'll just do that. That's fine. Okay, so let me go to my y equals. And actually, I think this was a function I had from last time. And this function that we have is going to be 3/4 secant x. Okay, so the first thing I'm going to do is I'm going to actually put my brackets in and put my 3/4 right in front. And then I'm going to multiply by 1 over, since this is secant, it's going to be cosine of the variable, which is right here, x. Close it off. That's my one bracket, and then I need the second bracket to close off that one up there. Okay. So when I hit graph, magic should happen. I hope it works. Oh, there it goes. You can see it. Whoa, of course my calculator died. So I think you saw it. If you notice really quick, I'm zoomed out a little bit. I need to probably change my scale. So let me change this to a -5 and a +5. There we go. Oh, yeah, look at that. Of course, my calculator's going to die. So when you're doing it, just stay on for a few minutes. You can see where the asymptotes are. The calculator just is trying to, I don't know if you know this, but the calculator doesn't actually have all of these in their memory. Like, they're using some numerical methods to graph these. And so anytime you see these really long straight lines like that, for the most part, they're just asymptotes. It's where the function doesn't actually exist. But remember, this is kind of what it looks like, what the secant function looks like. It's 1 over cosine. So again, we're kind of matching what's happening with the curve here. These minimum values, these relative minimum values that you see, so let me use my pen because I can get in there a little bit better. These relative minimum values right here are going to coincide with pretty much the maximum on your cosine curve, right? So here's here's a min, which is going to be a max on the cosine curve. Here's a max, which is your min on the cosine curve, and so on and so forth. So that's kind of what you do when you graph these. You can just use your device. That's perfectly fine with me. I have no problem with you doing that. So yeah, feel free to do that. I don't really have much more, honestly. This is one of those quicker lessons that the content really just speaks for itself. I personally prefer these lessons just because it is a bit of an extension to what we've already done. And if you've done well with the sine and cosine stuff, then the cotangent, cosecant, secant, and tangent stuff should hopefully feel like it's just a very simple extension of that. So if anyone has any questions, just let me know. I'll be more than happy to answer anything you have. And aside from that, I hope you have a fantastic day.